Good morning, students. My name is Mini Nagpal, and today we are going to do the topic corrosion. Now, what is corrosion? We have already dealt with this topic in first chapter, and you must be knowing about it. But let's do it once again with few more details added to it. Now, what is corrosion? Corrosion is when the metal is exposed to environment. It reacts with the substances present in the environment. It might react with carbon dioxide or moisture or oxygen or hydrogen sulfide. So, if it reacts with any substance present in the environment, the metal is said to be corroded, and the process is called corrosion. Now, corrosion is generally not beneficial. We see that silver tarnishes and turns black because of corrosion. Copper articles at home, if you have a jug which is reddish brown in color and you place water in it and you drink from it, because usually people do that. And if it is left unused, it will develop a green coating on it. That means the copper has got corroded. Iron, you all know, you all are aware that iron on corrosion gets rusted. Now, why silver turns black? We have given a reaction also over here. It turns black because it combines with hydrogen sulfide gas in the air and forms silver sulfide. Now, this silver sulfide is black in color, hence, it turns black. It appears to be black. Now, copper. Why the copper articles turn green? Because copper reacts with moisture, carbon dioxide, and oxygen present in the air and forms a compound basic copper carbonate. Basic copper carbonate is green in color, hence the copper articles turn green. Iron, when exposed to moisture, it forms a flaky substance on its surface which is called rust and which is ferric oxide. Now, students, there's very interesting fact about it. Like corrosion is never beneficial, but in certain cases, it is seen that corrosion is beneficial also. For example, in aluminum oxide and in zinc, not aluminum oxide, but in aluminum and zinc, the corrosion is beneficial. Because aluminium, when left on its own, it combines with oxygen in the air and forms aluminium oxide. Now, this aluminium oxide is a sticky layer and it sticks on the surface of the aluminium, thus preventing the aluminium underneath to come in contact with the moisture and the oxygen and preventing corrosion. So, corrosion becomes beneficial in case of aluminium, and even in zinc. Zinc also develops a coating of zinc oxide. So, this is what the corrosion is. Now, we are going to study that what are the essential conditions for iron to rust out. Now, there's an activity in the book. This activity is 3.14. As shown in the figure 1, we have taken 3 test tubes and we have placed iron nail in 3 of them. Now we are going to pour some water in test tube A and B. But the water we are going to pour in test tube A is a tap water, whereas in test tube B we are going to pour distilled water, boiled distilled water. Now, why we boil? So that any oxygen or any gases which are dissolved in the water should come out, and it is distilled. So, it is poured into the test tube B. About 1 ml of our oil is poured on in the test tube B after the water has been poured. The water which is poured is up to the same level in the test tube A and B. But in B, we also pour oil so that the water does not come in contact with the air present in the test tube, and we cork it. So we cork the test tube A and we put a cork on the test tube B as well. Now in test tube C, we are going to put calcium chloride. Now, as you can see in the first picture, we are pouring calcium chloride in test tube C and we cork it. Now, anhydrous calcium chloride, the purpose of anhydrous calcium chloride is that it will absorb all the moisture present in the air in the test tube. Now we leave this arrangement for few days, and after few days we see that in the test tube A the iron nail has got rusted, whereas in B the iron nail has not got rusted. Even in C the iron nail is not rusted. Now the reason for this is that in test tube A iron nail has is exposed to moisture as well as oxygen is present over there. So rust is formed when moisture and oxygen both are present. In test tube B, water is there, moisture is there, but there is no oxygen because it has a layer of oil. It cannot combine or take up the oxygen which is present in the air, and there is no oxygen in the water because it has been boiled. So only thing which is not present in test tube B is oxygen, or moisture is there, but so because of the absence of oxygen it does not rust out. In test tube C we have not poured any water, so no moisture is there. Even the moisture which was present in the air has been absorbed by anhydrous calcium chloride. So we see that the iron nail does not get rust out even in the test tube C. So what do we conclude? We conclude that two things are necessary for the corrosion of iron to take place. That is, for the formation of rust, we need moisture and oxygen. So moist air is necessary condition for rusting. So this activity proves that moist condition is necessary for rusting. Now there are number of methods to prevent corrosion. Every a lot of money is being spent on preventing the corrosion of iron. People paint, oil, and grease the articles so that the articles do not come in contact with the air and do not get rusted out. There are few other methods also which are used for preventing corrosion. One of it is galvanization. Now, galvanization is a method in which metal is dipped in the zinc metal to form a thin layer of zinc on its surface. And this process is called galvanization. When it develops a thin coating of zinc on its surface, the metal is said to be galvanized. Now, galvanization will protect the metal from getting, suppose it is iron, then it will protect the iron from getting rusted. Even if it develops a crack in the coating, if the zinc coating develops a crack, then also the article will not get rust out because zinc is very reactive metal and it will not let iron combine with oxygen. And then we have, as shown in the slide, chrome plating. Now, chrome plating is a technique of electroplating. Electroplating means by using electricity, we develop a thin layer of chromium onto a metal object. And this chromium layer is used to prevent the corrosion. It prevents the iron below to come in contact with air. You must have seen the chrome plating on the cycle handles and the rims of the bicycle, so they are generally chrome plating. Okay, now the another way of preventing the corrosion is to form alloys. Now, what are alloys? Why do we prepare? How do we prepare alloys? And why do we prepare alloys? Now, these are the questions that we have to deal with. Now, first of all, what are alloys? Now, alloys are a homogeneous mixture of two or more metals, or it may be a metal or a non-metal. It may be a mixture of a metal or a non-metal, or it may be a mixture of metal and a metal. We have large number of alloys. You are all aware of the bronze alloy and the steel, stainless steel, which is being used at home also. So those are alloys. Now, why do we prepare alloys? We prepare alloys to improve the properties of the constituent elements. Now, here I'll first of all take an example of gold. Now, pure gold, which is 24 karat, is very, very soft. You cannot use it for making any ornaments. Now, this has to be alloyed with either copper or silver. Then it becomes hard, and then the ornaments can be made. Generally, we have ornaments of 22 carats, and we do not have ornaments of 24 carats. So, alloying gold is helping to improve its property. That means it is giving it a hardness. Now, then again, we come to pure iron. Pure iron is very soft and stretches easily when hot. So we mix it with small amount of carbon to make steel. This improves the property of iron. It becomes hard and now it can be used to make variety of things. So why are we making alloys? To improve the properties. We make solder, which is an alloy of lead and tin. Now this alloy has a very low melting point, and this alloy is used in joining the electricity wires. Now when the wires are joined, this solder wire is kept over there. It melts readily and holds the two wires together, and thus helps in joining the two wires. So we are making alloys to, number one, to make them resistant to corrosion, and to have appropriate melting point, and to improve the properties of the constituent elements of which that alloy is made. Now, how do we prepare alloys? Alloys are commonly prepared by melting. First, metal is melted. That means the metal which is going to be in the largest proportion is melted, and then desired metals in the melted form in proper proportion is added, and then it is stirred, and then it is allowed to cool and solidify. The solid substance formed is an alloy. So this is how the alloys are prepared and why the alloys are prepared. Now we will study some of the alloys that are in our syllabus over here. As you can see in this table, we have brass, whose composition is copper 80%, zinc 20%, and it is used for making utensils, cartridges, etc. Now, you don't have to memorize the percentage, only you have to memorize the components. Like brass, it is made up of two metals, that is copper and zinc. You must know that. Bronze, it is made up of copper and tin, and it is used for making statues, medals, ships, coins, machines, etc. Solder, as I just gave an example, it is an alloy of tin and lead, and it is used for joining metals, soldering wires, electric components, and etc. Steel, over here is iron, and that is approximately 99% is iron and some percent is carbon, and is used for making tools, ships, machines, etc. Stainless steel has four components: iron, chromium, nickel, and carbon. And this stainless steel is used for making utensils and dishwashers. So these are the alloys that you have to memorize. Now there is also in the yellow block, it is given that there is an iron pillar near Qutb Minar in Delhi that was built 1600 years ago, and it has not rusted till today. So, we are dealing with this process of preventing rusting since ages, and alloying is one of the method to prevent corrosion. Thank you.